welcome you all to today's lesson, and in this lesson we are going to be talking about magnetism. We are going to know and understand what a magnet is and what are some of the properties of a magnet. So to start with, what is a magnet? What do you understand by the term a magnet? So magnetism, this topic called magnetism, we are just studying what a magnet is, character of a magnet. We are just focusing on the magnet. So what is a magnet? If a question comes in your exams and they tell you that define a magnet is a material or a substance that attracts and repels other materials. So a magnet is just a substance that attracts and repels other materials. That is a magnet, and a magnet has got certain properties. So we are going to start with the properties of magnetism. We are going to talk of the properties of magnetism. So property number one that we are going to start with. So property number one is that the end of a magnet is called the pole. So the end of a magnet, the end of a magnet is called the what? Is called, the end of a magnet is called the pole. This is what you need to know and understand. So the end of a magnet is called the pole. So if light magnet hangs on a spring, one end points toward the north, the other one on the south. So if this is a bar magnet, so we are going to get this. This is our what? This is our bar magnet. So I'm saying that the end of a magnet is called the pole. So this end here, the end of this magnet, this is a pole. So if this is the north pole, let's say this is the north pole, which means that this other end here, this other end will be the what? Will be the south pole. So that one will be the what? Will be the south pole. This is what you need to understand on this property number one, is that the end of a magnet is called the pole. This is property. So we are talking about properties of magnetism. So this is property number one. We go to property number two. Property number two is that what we need to understand is that same poles repel each other. This is what you need to. This is property number two. Same poles repel each other. So what do I mean? If you bring two magnets here, this is a bar magnet and this is a bar magnet. This is two bar magnets. So if this is the north pole and this is the north pole, here this is the south pole, that one is the south pole, like this. So if these two magnets are brought together, which means that we are going to have what? Repulsion here. These will not attract. You know that how do magnetic field lines move in a magnet? They move in this direction. This is how they get to move, in this direction. Have you seen? They move like this. This is how they are going to move. So they move from north pole to the south pole. This is how they move. So in here, they will be going this other side. They will also be going this other side. This is how they are going to be moving. So magnetic field lines move from the north pole to the south pole. So no attraction here. What we are going to have here will be called repulsion. So this is what? Repulsion. This is repulsion. So this is a state, that's a state that like poles will repel. I think you've heard of that, where we say like poles repels. This is a property. So we are saying that same poles will repel each other. There will be no attraction here. There will be pull. There will be what? There will be repulsion. They are going to repel. So this is what we mean when we talk about that property. Then the other one, the third one that we are going to discuss, the third one. So what is the third one? Is that different pose attracts. So different pose attract each other. This is what you need to know and understand. So different poses are going to attract each other. Hope you are able to see this. You are able to get the concept. Different poses attract each other. So whenever you've got different poses are going to attract each other. Let's say you've got this bar magnet, and this is a bar magnet. So this one is, if it is the north, this one it is the south. So here we've got north, here we've got south. So this is a bar magnet. So if these two are brought near towards each other, what we are going to experience is that there's going to be attraction here, which is taking us to a state that states that different poles are going to attract. So here we are going to have these lines that are going to go there. So this is what it means when you say attraction like this. These other ones will move that other side. So this is how they get to move. They are going to move this other side. Even these will be coming this side. Even these like this. Have you seen? So this is what we mean. So here we are having different what? These are magnetic field lines. These ones that I'm doing this. These are magnetic field lines. These ones will go there. Go there. So these are what? Magnetic field lines. This is what I mean. So these are some of the properties that you need to understand. These are properties that you need to get and understand. So let us now look at property number 4. So property number 4, we are going to understand it. It is very simple. The same one which I gave at first. So property number 4, it is very simple. I won't write it down. So property number 4 states that I said that a magnet is a material that attracts and repels other materials. So magnet attracts some materials. We can talk of iron, cobalt, and steel like that. These materials that can be attracted to a magnet are called magnetic materials. So I want you to get this one. So let me lab this part. So I want you to understand all the points that I'm trying to illustrate here. All the points that I'm trying to bring out here. So materials that are attracted to a magnet are called magnetic material. They are called what? Magnetic materials. These are called magnetic materials. This is what you need to know and understand. So if someone asks you a question, what is a magnetic material? A magnetic material is a material that is attracted to a magnet. So other materials, like we've got other materials, these examples of these magnetic material, we can talk of iron. Iron is one of the examples. We can talk of cobalt is one of the examples. We can talk of steel like this. These are some of the examples. So if we have magnetic materials, we also have non-magnetic materials. We also have non-magnetic materials. This is what we have, non-magnetic materials. So once we have magnetic materials, we also have non-magnetic materials. So what are non-magnetic materials? Non-magnetic materials, these are materials that can't be attracted to a magnet. So they can't be attracted to a magnet. They are called magnetic materials. They can't be attracted to a magnet. This is what you need to know and understand. So these can't be attracted to a magnet. Whenever we are talking about non-magnetic materials, these are materials that can't be attracted to a magnet. What are some of these examples? We can talk of copper is one of them. We've got copper. We also have the common ones that we have. We can talk of a paper. Have you seen? We can talk of a paper. You can talk of wood. These are some of the things that we know. We can talk of plastics. So all these, I believe we know them. These are what? Plastics. So all these are non-magnetic materials. All these are non-magnetic materials. So we need to know these. We need to make sure that we understand all this data that I'm trying to illustrate here. So make sure that you know this part, you understand this part. With this, you won't fail any question that may try to come in an exam related to magnetism. So I want you to get this, and I want you to understand this topic very well, so that each and every question that you are going to encounter in your exams won't be difficult. So this is the first part that you need to understand under magnetism. Let us look at another part, which is called induced magnetism. So we look at induced magnetism. So this is what we are going to start with. Induced magnetism. Induced magnetism. This is what we are going to start. So what is induced magnetism? What do you understand by this term when we say induced magnetism? Induced magnetism is the what is the, so I'm going to put the okay, like this, we are able to see. Okay, so it is the what? Temporary. So I'm going to give you this definition. Is the temporary magnetization. This is the temporary magnetization. Temporary magnetization of a magnetic material. So of a magnetic material when it is pressed. So when it is pressed or near. So when it is, let me do this. When it is pressed near or in contact with a magnet. So this is the definition of induced magnetism. So what is induced magnetism? Induced magnetism is the temporary magnetization of a magnetic material when it is pressed near or in contact with a magnet. This is what you need to understand. So if a nail if a nail is pressed in contact with a permanent magnet, the nail is magnetized. In other words, that nail will also be able to attract another nail. This is called induced magnetism. I want you to get these things that I'm trying to illustrate here. So you've got a what? You've got a nail here. This is a nail. Let us get this nail. This is a what? This is a nail. A nail is like this. This is a nail. So when this nail is brought near a magnet, so when this nail is brought near a what? Near a magnet. Let's say it is brought near. This is a bar magnet. So this is a nail. This is a bar magnet. We've got the North Pole and the South Pole. This is a bar magnet. So when a nail is brought near a permanent magnet, so when it is brought near a permanent magnet, what happens is that this nail will become magnetized. So when it becomes magnetized, which means that it will be able to attract other materials. So this nail, when it is magnetized, the nail will be able to attract other nails. So let's say that the end of a nail, this nail which is connected to the north, have you seen, to the North Pole of this magnet? So when it is connected to the North Pole, let me say it is connected to the North Pole. So just to make everyone understand, I'm going to do this. Here we've got the North Pole, there we've got the South Pole. So this nail is connected. So I was saying that the end of a nail, nearer the end of this nail, nearer to the what? Nearer to the north pole of this magnet. So it must be a permanent magnet. So when it is brought near the north pole of this magnet, the end of this nail, it becomes an induced south pole. It becomes the opposite. Have you seen? So if it becomes this one become the south pole, then you know that otherwise the other end will become the what? Will become the induced north pole. So I'm using this word called induced, telling you that it is coming in contact with a magnet, a permanent magnet. So when this end of a nail, when it is brought or when it is nearer to this north pole of a permanent magnet, it means that this side here, it will become the induced south pole. Then this other one will become what? Will become the north pole. This is what I mean. So the pole that is nearer to this part of a permanent magnet. So if it was brought near here, so this, if it was brought here, if this is another nail. So when this nail is brought, this nail nearer to the south pole, so this one becomes induced what? North pole. And this one becomes the what? The south. So this one which is nearer to this pole here, this one becomes induced south pole. It is nearer to the north. Have you seen? It is nearer to the what? North. So it is not a south pole, but it is the induced south pole. Even this one that is nearer to the south pole, this one becomes the induced north pole. These are points that you need to get, and these are points that you need to understand. So I want you to get this. I want you to understand all these things that I'm trying to talk about. So each time we are talking about induced magnetism, this is what we mean. So what is induced magnetism? Induced magnetism is the temporary magnetization. Have you seen? There is this keyword, which is what? Temporary magnetization, which means that a magnetic material will only become a magnet for a short period of time. So it will just be made a magnet for a short period of time. Have you seen? So that one will be made a magnet for a short period of time. Not really that it will be a magnet for a longer period, but it will just be made a magnet for a short period of time. So this is what you need to know and understand. So now let us look at some of the differences between these magnetic materials. I listed some of the examples. So let us look at some of the examples of these magnetic materials. So we only focus on two. So we are just going to focus on these two. And these usually come in your exams. These usually come in your exams under magnetic materials. So magnetic materials. So let us look at magnetic what? Materials. So magnetic materials. Then I've told you that we are just going to talk about two of them, which are what and what? We are going to talk of iron and steel. What are some of the differences between these two? So there are differences. We must give them in terms of their magnetic materials as magnets. So this is where we are going to judge them. We are not supposed to give those differences that we know this one is this in color, this one is this. No, this one is strong. These are not in that way, but as what? Magnetic materials. So their differences should be in their magnetic materials. In terms of magnets, how can you differentiate these two? So iron and steel are common magnetic materials. These are common magnetic materials. But they have some differences in their properties. So these have got differences in their properties. These have got some differences in their properties. So what we need to know is that the first one that so I'm going to start with I'm going to say this is iron here. So this is for iron. This one is for steel. This is what I'm going to do. So this one is for steel. So I'm going to do this. So I'm going to form a table that will help us differentiate these two. So here I'm going to say magnetize. This is the word that I'm going to talk about. Magnetize. Have you seen magnetize? So magnetize here. So magnetize, what I mean is that how is iron when we are magnetizing? How is iron and steel? How are these two when we want to magnetize them? To magnetize is to make a magnet. So how do they behave when we want to make these two magnets? So when we are talking about iron, iron is what? Iron is easy and strong. So this one is easy and what? Easy and strong. You discover that we use iron in some transformers because this one is easy to magnetize and strong. But whenever we are talking about steel, steel is what? Hard. It's very hard to magnetize steel, but it is very weak. This is what you need to understand. So this is the first part. We move to the second part. So in terms of their magnetization, discover that this one is very easy and strong, but this one is very weak, is very hard and weak. We move to demagnetizing. So I'm going to say to demagnetize. This is demagnetization. So demagnetize. So let me write it properly. So this is what okay, demagnetize. So what does it mean when we say to demagnetize? To destroy a magnet is to demagnetize. To make a magnet lose its magnetic strength. That's what it means to demagnetize. So in terms of demagnetization, how is iron? So iron is very what? Easy. It's very easy to demagnetize iron. This one is very easy. But this one, very hard. That's why when a steel becomes a magnet, it can become a magnet for a longer period of time compared to iron. Because this one, iron, is very easy to demagnetize it. But when we are talking about steel, very difficult. We move to the other part, which is what? Application. Where do we apply them? So this is what? Application. Where do we apply them? Where do we get to apply these? Their application. So also needs to talk of their application. So this one, you discover that we use iron in what? Electromagnets. Magnets. So in electromagnets, we use what? We use iron. Iron is used in electromagnets. Then these ones are used to make permanent magnets. So whenever they want to make a permanent magnet, they use steel. So this is permanent magnet. So there it is permanent magnet. Whenever we want to make a permanent magnet, we use steel. But these ones, electromagnets. Have you seen electromagnet? Then what are some of the examples of these? We talk of examples. What are some of the examples of these two? What are some of the examples? So one of the examples is that this one, in transformers, that's where you find this. You can talk of a transformer. Have you seen a transformer? An electric bell. So in that electric bell, we find what? So we also have that one as its example. So we've got what? Electric bell. electric bell, we find what? These ion, which are we find ion here, these ones. But an example of this one, steel. Steel, we use steel in a what? DC motor generator. So I want you to get this, and I want you to understand all these things that I'm telling you. These are simple things that you need to know. And the other one here, so here I'm going to say these are named, what do we call them mostly? So I'm going to say named. What do we call them mostly? So these ones are called soft, these ones are called soft magnetic materials. These are called soft magnetic materials. This is what they are called, soft magnetic materials. What about steel? Steel, these are called hard magnetic materials. Hard magnetic materials. This is how you need to understand them. So you need to make sure that all these things that I've given you here, you understand them and you know them. So you need to make sure that you understand them and you know them. You need to make sure that you understand these and know them, such that if a question comes in an exam, you'll be able to answer that question. You are going to know on how to go about that question and all the things which are necessary for you to handle that question. So I want you to get all these. Make sure you are writing these things down. Make sure you are able to understand this, such that if they come in an exam, you'll be able to answer them. Magnetism is very important. You need to know this. You need to understand this. So now, let us look at another part. Let us look at another part. So let us look at another part. Hope you are able to get the concept clearly. You are able to understand. Let us look at it. Okay, let us look at the magnetization. We look at what? Magnetization. So let us look at the magnetization. So magnetization. So what we are really talking about is how to make a permanent magnet. How can we make a permanent magnet? So how to magnetize a hard magnetic material. So this is what we are talking about. How can we make a magnet? How can we make a magnet? So this is what we are really talking about. How can we make a magnet? How can we make a magnet? So we want to know how we can make a magnet. How can we make a magnet? The first thing that you need to know, there is one method that we usually talk about. We've got one method, and that method is called stroking method. It is called what? Stroking method. So these are methods of making a magnet. So magnetization is just making a magnet. Have you seen making what? Process of making a magnet. So these are, we are just talking about methods of making magnets. So process of making what? Magnets. That is what we are just talking about, to be brief. So if a permanent magnet stroke along a hard magnetic material, the hard magnetic material is magnetized and it is changed into permanent magnet. So I think you know what I mean when I say stroking. We are able to know this. So let us say this is a what? This is a let me get this. This is a what? Let me put a smaller one like this. This is a what? This is a hard magnetic material. You know what a magnetic material is? To do at first. So when it is stroking, which means that you get this one like this. Have you seen? This is a magnet. This is a magnet. We've got the south pole there, then we've got a north pole there. So I'm stroking it. It is moving in this direction. Have you seen? I'm stroking like this, moving in this direction. This is how it is moving. This is how it is moving. So when it goes like this, stroking, you're stroking like this, stroking like this. Have you seen? So what I mean by stroking, this is what I get to mean. You get this, you get like this, I'll get this, then I start doing it like this. Have you seen? I start doing it like this. This is what I mean. So when I start doing it like this is stroking. Have you seen? Doing like this, doing like this. This is the what? What is this? This is a magnet. Then this is a magnetic material. So I'm stroking, doing like this, stroking. This is a magnet. This is a magnetic material. So if this magnetic material is hard, which means that what I'm making here, I'm making a permanent magnet. By using what method? This method is called stroking. Doing this. This is what I'm doing. Have you seen? Doing this. Like this. This is called what? Stroking. This is what I'm actually doing here. So here where it is landing. Have you seen where it is landing? The first part where it is landing. Here where it is landing. This part will become the north pole. Then this one will become the what? The south pole. So don't confuse this one with the first part, which I said that when the north pole becomes, or when it is near a certain pole, that one becomes an induced pole. The opposite. So if that one I said that, hope you are able to relate, you are able to understand. So when this is a what? This is a nail. It is brought near the north pole of a magnet. This part of a nail becomes the induced south pole. So here we are not talking about those things. So but here, where it is starting here, where it is starting from, if it is the north pole here, where it is starting from, it will become the north pole. It's different with the induced. Induced, I said, if a magnet, this is a nail, then we've got this. This is north and south. So where it is starting here, when it is pressed near, so here it is pressed. So it is just pressed near what? Near the north pole of a magnet. So near the north pole of a magnet. So it becomes the what? The opposite of this. It becomes the induced south pole. That is under induced magnetism. But we are not talking about here, we are talking about stroking method. When it is stroked like this. Have you seen what I'm doing when it is stroked like this? This one, where it is starting from, this part, it is called, it will be the what? The north pole. Then that one will be called the what? The south. This one will be called the north pole. This one will be called the south pole. So these are terms that you need to know and understand. So we need to know and understand. These are terms that we need to get. So this is what it means when we are using stroking method. We move to the other one. So the other one is called electric method. Electric what? Electric method. This is electric method. This is the second one that we are going to talk about, which is electric method. So if a hard magnetic material is pressed into a solenoid, so this one is being pressed into a what? A solenoid. This is also called what? Direct current. So direct what? Current. Like this. So a hard magnetic material is magnetized and it is changed into a permanent magnet. It becomes a permanent magnet. So you know what we mean when I said it becomes a permanent magnet. So we are using what? Steel. So once you use steel, steel becomes a what? A permanent magnet. So when it is pressed into a what? Electric solenoid. So an electric solenoid is like this. This is an electric solenoid like this. Like this. I'm going to put this. Then there are these going like this. Have you seen the way they are moving? They are moving in that. Then we've got a cell here. So I'm going to get a cell here like this one here like this. This is what we are having. So now this one here, this is a what? This is a hard material now here, which is placed here. This is electric solenoid. So this material which is in here will become magnetized, and hence it will become a permanent magnet. So this is the what? Hard magnetic material. This is hard magnetic material. This thing here, it is called hard magnetic material. So it is hard magnetic what? Magnetic material. So this one will become a what? This one will become a magnet. So one thing you need to understand that this is the best method to make powerful magnets. This is the best method to make what? Powerful magnets. So if a question comes in your exams, which method do we use to make a powerful magnet? It is called electric method, where we use the electric solenoid. So the magnet which is made with electric solenoid is called electromagnet. Have you seen electromagnets? Electromagnets. So this is what you need to know and understand. This is what you need to know and understand. So we need to make sure that we understand this part. We get all the important things that I'm trying to illustrate here that you need to get. So these are some of the things that you need to know. These are some of the things that you need to understand. The other thing is that how can you tell when it is brought like this? How can you tell that this is the North Pole, this is the South Pole? How can you tell? So direction of current, if the direction of current is going in this way, have you seen? So this is the direction of what? Current going in this way. So if I do this, it goes like this, it's on like this. When it is going like this, have you seen? So what you need to know and understand is that as long as it is moving, so this one will be in that way, this one will also be in that way. Have you seen? It will be in that way. So when it is going like this, it is going like this. This, have you seen? So maybe to make, when it goes like this one, so it is going that way. They are pointing this side, they are going this side. This is the side where they are going. Have you seen? They are going which side? They are going this side. This is where they are going. So to make you understand is that where they are going, they are so they are moving this direction. They are going to that direction. This is how they are moving. So I'm going like this, going like that. So if they are moving in that direction, what you need to, where they are starting from here, where they are entering, this is called the North Pole. Then this is called the South Pole. You can even tell how particles, how magnetic field lines gets to move. They move from the what? They move to the North Pole to the South Pole. This is how they get to move. So this is how you need to understand. This is how you need to know. So make sure that you know this part, you understand this part very well. So let us now look at another part, which is magnetization, demagnetization. So we look at demagnetization. So this was magnetization. We also look at demagnetization. So this same one, magnetization, then we just say demagnetization. This is what? Demagnetization. We look at demagnetization. Let me do this. Let me just write it. Demagnetization. So demagnetization is the process of destroying a magnet. So here we are just talking about destroying a magnet. How can you destroy a magnet? One is by heating. So when a magnet is heated to its highest temperature, which means that we are going to destroy a magnet. So once a magnet is heated to a higher temperature, it will lose its magnetism very quickly, which means it is no longer going to be called a magnet. The second one is what? Hammering. So I want you to know all these. Hammering. So if a magnet is hammered many times, so if a magnet is hammered many times, the magnetism becomes weaker and weaker. This is how you need to understand these things. It becomes weaker and weaker. And it will lose its what? Its magnetism. So these are things we need to know and understand. So a magnet, when a magnet is pressed into an electric solenoid of an AC supply, the magnet is withdrawn far away from the solenoid. So this one here, the third one that I'm talking about, I'm saying use of what? Use of alternating current. So alternating current for the solenoid. This is what we are talking about. So when I told you that there we use what? We get to use this one that we are used should be a what? Direct. There should be the direct current. Should be direct current. That one that we talked about, electric solenoid, electric method, it should be a direct current. So when we use the opposite, which is this one, alternating current, AC, which means that we are going to make a magnet lose its magnetism. So these are some of the terms that we need to know and understand. So this is what you need to get and understand. So let me give you a picture of this. Let me put something here. So this is the electric solenoid. So I'm going to say this is a material like this. So these are interlinked like this. Just like that. Like that. Like that. I'm just going to illustrate this. So this is AC supply. AC supply. This is AC supply. This is AC supply. This is what I'm going to do. So what I mean is that, so this one is, we are saying that it is being what? Withdraw away. Far away. Have you seen far away? So withdrawing far away. So what I mean is that a magnet is pressed inside the what? Solenoid. We know that it's pressed inside the what? This solenoid. So they are supposed to be E. So solenoid with an AC supply. This is the AC supply. The magnet is withdrawn far away from the solenoid, and this process is repeated. Then finally, the magnet is demagnetized. Hope you are able to understand this. Hope you are able to get the point. So this is all that you need to know under demagnetization, process of destroying a magnet. Some things that I would also like you to know is that you need also to have information on electromagnets. We have electromagnets. You need to have information on electromagnets. You need to know what electromagnets are. Information on electromagnets. So this is one word, electromagnets. So this is electromagnets. You need to have information on this topic, very important. So electromagnets, you need to have information on electromagnets. So iron is commonly used as the core of electromagnets. We normally use iron in this case. So iron is normally used because it is easy to magnetize it and also to demagnetize it. So it is very easy to control the magnetism. Have you seen? So here, what I'm saying that we normally use what? We normally use iron. So iron is a what? Iron is a core of electromagnets. Electromagnets. So electromagnets. Electromagnets. This is what you need to know. So electromagnets. Why do we use iron as a core of electromagnet? Because it is very easy to magnetize iron and very easy to magnetize it. So the strength of magnetism depends on these things. So strength, I want you to understand all these points. Strength of magnetism. Strength of magnetism. So strength of magnetism depends on, the strength of magnetism depends on, one, it depends on what? It depends on current. It depends on current. Two, it will depend on the number of what? Turns per unit length of the solenoid. The third one that you need to talk about is the material of core. This is what you need to understand under the electromagnets. So under electromagnets, the strength of a magnet will depend on current. Two, it will depend on the number of turns. So say number of turns per unit. Number of turns per unit length. So per unit length of the solenoid. Per unit length of the solenoid. Then lastly, I also talked about the material. So talked about this one, which is the material of core. The material of core. So this is where the strength of the electromagnet will depend on. This is what you need to know. This is all what you need to understand. So let's make sure we understand this part. We make sure that we know this part. So this is just an introduction to magnetism. We are yet to go deeper than this. We are yet to improve. We are yet to go further. We are going to talk about transformers. All these things, we are going to cover them. So we are going to discuss through a lot of things. So let's make sure that we are following. We are not missing any lesson. We are going to talk about AC generators. We are going to talk about all those things there. We are going to talk about electromagnetic effects. All those things will be covered. Magnetism is an important topic. So let's make sure that we cover these. We understand all this. So this is where we are going to end for now. Thank you so much. So make sure that we've written down these things. We are able to understand them clearly.